Alright, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So we will continue our chapter number 7, which is Introduction to Probability. So today topic is about tree diagram. Right, we need to understand tree diagram. Actually, tree diagram is a part of probability. It's a pictorial representation of a probability, right? Right. So a tree diagram is a diagram that can be used to portray a probability of an event. So the tree diagram is sometimes known as a probability tree. So this is an example of tree diagram. So this is an example of tree diagram. So let's say we have two event A and B. So we can put two cabang dekat sini, A and B, right? So after event A, so let's say we have event D. So this one we call as a probability of D, given that A is already happened. So this one also probability of D complement, given that A is already happened. So the total probability of this side, it should be equal to 1, right? So to note that the above tree diagram, probability of A plus probability B is also equal to 1. So this side, the total of the probability of this side should be equal to 1. The total of this probability should also equal to 1. So now, let's look at how to draw a tree diagram. Let's look at example number 7.15. A coin is tossed 3 times. So we need to draw a tree diagram to show the event and the probabilities. So coin, we have two possible outcome, right? Sample size for a coin is head or tail, right? So let's say we have the first toss, we have head and tail. So this is going to be our first toss. So the probability of tossing of getting head should be equal to 1 over 2. The probability of getting tail also 1 over 2, because if you look at the sample space, we have two possible outcomes. The probability of getting head here should be equal to n h divided by n s. So this is a basic probability formula. So we have one head divided by number of in sample space we have 2, so 1 over 2. So this is going to be the first toss. Right, for the second toss, if the first toss you got head, the second toss you still have two possible outcome for tossing a coin, right? Because a coin you have only two possible outcome, either head or tail, right? If the first toss you get tail, the second toss you still have two possible outcomes. So this is going to be our second toss, right? So this is our second toss. So the probability of getting head after getting head is also 1 over 2, right? Because the probability of getting head is 1 over 2, and probability of getting tail also 1 over 2, right? This is 1 over 2, right? So if the first toss you got head, the second toss you got head, the third toss you still have two possible outcome, either head or tail. These steps are same for the rest of the outcome, right? And the probability also same, 1 over 2, 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 and 1 over 2, right? So the sample space of tossing a coin 3 times should be, the first toss you dapat apa? Head, head, head. So you're going to have the first outcome is H, H, H. The second outcome, it should be H, H, T, head, head, and T. And the third outcome, right? The third outcome should be head, tail, and head. The fourth, head, tail, and tail. This one should be tail, head, and head. This one, tail, head, tail. And this is going to be tail, tail, head. And the last one is tail, tail, tail. So the sample space of tossing a coin 3 times should be this one, right? And head, tail, tail, and then tail, head, head. This one, tail, head, tail, tail, head, tail, and then this is tail, tail, tail. Right. To know how many possible outcomes are there, so if you can see the first toss, you have 2 possible outcomes, right? The second toss, you have 2 possible outcomes. The third toss, you also have 2 possible outcomes. So by using the counting rule, first possible outcome multiply with second possible outcome, third possible outcome, you should get at 8 possible outcomes. So if you count the sample space for tossing a coin 3 times, you should have n as equal to 8, right? So this is how we draw a tree diagram, right? So before we go for Bayes theorem, let's look at one example in a final exam question. So let's say we look at example number 7.16. In example number 7.16, a company has 2 machines, X and Y, right, to manufacture a product. So of a total output, 55% produced by X, 45% produced by Y. Of the product produced by X, 9% are defective, and as are produced by Y, 7% are defective. So first you need to understand the statement. So we have 2 machines, either X and Y, and we have 2 machines X and Y. So the probability, the total output of X is 0.55. So this is the probability of X, right? And the probability of produced by Y is 0.45. So this is probability of Y. And if you can notice, the total of these 2 values should be equal to 1, right? So always equal to 1. You cannot less than 1 or more than 1, right? So now, of the product produced by X, 9% are defective. So it should be either 2 outcomes, either defective or non-defective, right? 9% defective, 0.09. Non-defective is 0.91, right? It should be a complement of defective, right? So this is the probability of D given that X is already occur. So this is the probability of D complement given that X is already occur, right? So for Y, it still have a same outcome, either defective or non-defective, right? If you can see, as a product produced by Y, 7% are defective. So 0.07% defective. Non-defective is 0.93. It's a complement of defective. So this is the probability of D given Y. This is the probability of D complement given Y, right? So this is the tree diagram. So let's look at another example, right? So now example number 7.17, right? So now example number 7.17, a construction company has tendered 3 projects, right? Project Q, Project R, Project S, right? So now we have 3 projects, right? To draw a tree diagram, we have 3 projects: Project Project Q, R, and S. The probability of getting tender projects are 0.4, 0.3, and 0.3 respectively. So the probability of getting project Q is 0.4, project R 0.3, project S 0.3 respectively. So now if you see, if you total up all the probability value, you should get equal to 1, right? Now let's look at the next statement. The probability of getting project to be complete on time are 0.2, 0.82, 0.7, 0.68. So for the project Q, there are two options, either project complete on time or project not complete on time. Right? Same goes to R, project complete on time, project not complete on time. And S, project complete on time, project not complete on time, right? So the probability value here, 0.82 complete on time for Q, 0.82. So the complement should be equal to 0.18, and the total should be equal to 1, right? For R, the project expected to be complete on time is 0.70, and this is 0.30. And this one for C and for S, complete on time is 0.68, not complete on time is, the complement is 0.32, right? If you can see, this is the probability of Q, right? And this is a probability of R, and this is a probability of S. And 0.82 is probability of C given Q. This one, probability of C complement given Q. This is probability of C given R. This is a probability of C complement given R. And this one, same, probability of C given S, probability of C given C complement given S. Because this is a probability of C complement, given that S is already occurred, right? So so far, do you understand the concept of tree diagram? Can you comment on the chat room? Right, good. Good. Now, let's move to the Bayes Theorem. Bayes Theorem, the concept are same as a tree diagram. You should know the conditional probability. So in a conditional probability, let's review our knowledge on conditional probability. The conditional probability, let's say probability of A given B is equal to probability of A intersect B divided by probability of B, right? Another one is probability of B given A is equal to probability of A intersect B divided by probability of A. Anything has happened should be at denominator. And everything already happened should be at denominator. Another thing that you need to understand is idempotic law, means probability of A intersect B should be also equal to probability of B intersect A, right? See, this is a same value right now. So now let's look at this one. Bayes theorem, if A1 and A2 are mutually exclusive event, so B is another event in the experiment, this can be illustrated as tree diagram below, right? This is a same concept, right? So probability of A1, so probability of B given A1, right? Probability of B given A2, right? So this is based on conditional probability, right? It's hard to explain if you have a long value of A, right? So let's look at this one. I need to draw to you a simplest way to explain to you. Let's say we have a lake here, right? Let's rename this lake as B, right? So in this lake shared with the let's say 4 districts, right? This is district A1, district A2, district A3, and district A4, right? So if you can see here, this value is, this part is the intersection between A1 and B, right? This is the intersection between A1 and B, right? So this is also intersection between A, let's say I use another color. This is the intersection between B and A2, right? And this one should be the intersection between B and A4, right? Right. And this one is the intersection between A3 and B, right? So this is A4 intersect B, this is A2 intersect B, this is A3 intersect B. So if you want to find probability of B, if you want to find B basically, right? If you want to find B, so you should add A1 intersect B plus A2 intersect B plus A3 intersect B plus A4 intersect B. So if you add all the intersection with B, right, you will get the whole B, right, based on this illustration lah. So now let's say example number 7.16. Wait a right. So let's look at example number 7.16. So we already know the company have two machines, X and Y, right? And the probability of the product produced by X is defective is 0.09. Right? The probability of product produced by Y is defective is 0.07. Right? So this is a tree diagram. We already answered the first question. So now we want to know what is the probability of non-defective product. So the probability of non-defective product is, we want to find probability of D complement, right? So if you can relate with the diagram that I showed to you, this one, this lake, if you want to find B, right, you need to add all the intersection with B, right? Then you will get B, right? So if you look at this tree diagram, so D shared with X, D complement also shared with Y, right? So if you want to find D complement, so we need to add the intersection between X and D complement, Y and D complement. So it should be equal to probability of X intersect D complement plus probability of Y intersect D complement, right? So if you want to get D complement, you should add the intersection between D complement. So the problem is, we have the value of probability of X, we have the probability of D complement given X, but we don't really have the value of intersect X intersect DX, right? So now back to the basic conditional probability, right? This is the conditional probability formula, right? If you twist the value, if you want to find probability of A intersect B, it should be probability of A intersect B you bring B over there, it should be probability of B multiply with probability of A given B. Same goes to this one. If you want to find probability of A intersect B, it should be equal to probability of A multiply with probability of B given A. So you just twist the formula. So to find the probability of D complement, right? So you should multiply probability of X multiply with probability of D given X. So probability of X multiply with probability of D complement given X plus probability of Y multiply with probability of D complement given Y. Right? Benda yang sama. So this one should be equal to 0.55 multiply with 0.91 plus 0.45 multiply with 0.93. So this one should be equal to how much? This one should be equal to 0.919, right? So the product is non-defective is 0.99. So far, do you understand the basic concept of Bayes theorem? This is not a Bayes theorem yet. This is a towards Bayes theorem. So far, do you understand the concept? Can you comment on chat room? Alright, good. Now, let's look at another example. Example number 7.17, right? So we already draw a tree diagram, right? So now we have three tenders to be a construction company has tenders 3 project, right? Project Q, R, and S. So complete on time is 82%, not complete on time is 18%, and so on. So now we want to find the probability of 3 project is delayed to complete on time. So delayed to complete on time is C complement, right? So this is a C complement, delayed project, right? So if you want to find the probability of C complement, right, you should add all the intersection with C. Probability of Q intersect C complement plus probability of R intersect C complement plus probability of S intersect C complement, right? So this one should be equal to 0.4 multiply with 0.18. So you need to multiply these two together, right? 0.3 multiply with 0.3 plus 0.3 multiply with 0.32. So this one should be equal to how much? Right? It should be equal to 0.258. Right? This is how we find the value lah. Okay? Hope you understand. Right, let's look at example number 7.18 to enhance our understanding on this topic. Kita belum masuk Bayes theorem lagi. This is towards Bayes theorem. Right, now let's look at example number 7.18. So out of 120 diploma students, right, 72 are female students, and of these female students, 52 enroll for the first degree program. Of male students, 25 enroll for the first degree program. Right. Based on this statement, we have 120 students, and we have basically male and female student. Right. They are said that 72 are female students. So the probability of F Probability of F should be equal to 72 over 120 lah. So this one should be, kita biar ni dulu, right? 72 over 120, right? And probability of M, 120 minus, so 120 minus 72, you got 48. 48 over 120. So this is 48 over 120 lah, right? So now out of female students, right, there are two possibilities: either enroll for the first degree program and not enroll for the first degree program, right? Enroll for the first degree program, not enroll for the first degree program. Right, before I forgot about the tree diagram, when you are using the notation here, you should put some notes here, right? M is equal to male students, right? F should be equal to female student, right? And D is equal to enroll first degree, right? And D complement is not enroll to the first degree, right? You should put some notes so I can understand what is the notation that you use, right, in the tree diagram, right? So now, out of female student, 52 enroll for the first degree program. So this is probability of D given F, right? It should be equal to 52 over 72, right? We have 72 female student, and of course 52 minus 72 minus 52 should be equal to 20. So the probability of D complement given F should be equal to 20 over 72, right? For the male student, 25 enroll for the first degree program. Probability of D given M should be 25 over 48, right? And the complement is probability of D complement given M should be 45 minus 25, 48 minus 25, it should be equal to 23 over 48, right? This is how we draw a tree diagram, right? Now, B, find the probability that a student is enrolling for a first degree program. So enrolling for a first degree program is D, right? If you want to find probability of D, you need to add all the intersection with D, right? Probability of M multiply with probability of D given M plus probability of F multiply with probability of D given F, right? This is also equal to probability of M intersect D plus probability of F intersect D, right? So this one should be 48 over 120 multiply with 25 over 48 plus 72 over 120 multiply with 52 over 72. So this one should be equal to 0.642, right? So I hope you understand the concept of finding Bayes theorem, right? Denominator of the Bayes theorem. So now, let's look at the formula for Bayes theorem. So for the Bayes theorem, it says that if you want to find probability of A1 given B, right? If you look at the tree diagram, we have the value of probability of A1, probability of A2, and this is probability of B given A1. This is probability of B complement given A1. This is probability of B given A2. This is probability of B given A2. Right. If you want to find the probability of A1 given B, right, if you look at the tree diagram, we don't have the probability of A1 given B. What we have is probability of B given A1. Right. By using the basic conditional probability, right, probability of A1 intersect B divided by probability of B, right? So that's why we need to find probability B. If you want to find probability B, right, we multiply, we add all the intersection between B, right? So this is probability B. So kita akan dapat di bawah ni lah. And then probability of A intersect B, we just multiply these two together, right? They're very simple to understand. We just need to understand the basic conditional probability, right? So now, let's look at example number 7.17, right? Now, we already draw a tree diagram. We already know what is the probability of project will be delay, right? And then if the project is complete on time, find the probability that project is S. So if the project is already complete on time, so this is given, right? Project is already complete and we want to find the project, the probability that project is S, right? This is what the question C asks us. Right, we want to find probability of S given C. So if you look at this tree diagram, we don't really have the probability of S given C, right? So now, to find the probability of S given C, right? So this one should be, right? I buat ni dulu, Allah. Right, probability of S given. Given C, it should be equal to probability of S intersect C divided by probability of C, right? So we already know the probability of C complement, right? Probability of C should be 1 minus probability of C complement, right? And probability of S intersect C, it should be somewhere here, right? 0.3 multiplied with 0.68. So this one should be 0.3 multiplied with 0.68 divided by 1 minus 0.258, right? So this one should be equal to 0.275. So this is the value of probability as given C. Right, we just reuse the knowledge on conditional probability. Right. So now look at example number 7.18. Right. We already draw the tree diagram. Right. So we already find the probability of student enrolling for the first degree program, right, which is 0.64. So now the last question is, given that a student is not enrolling for the first degree program, find the probability that the student is male. So now, let me use another color. Right. So probability of the student is not enrolling for the first degree program. So we already know that the student is not enrolling for the first degree program. We are interested to know that what is the probability that student is male. So now, by using our knowledge on conditional probability, probability of M intersect D complement divided by probability of D complement, right? So probability of M intersect with D complement is this one, it should be equal to 48 over 120 multiplied with 23 over 43. Right? So divide by the probability of not enrolling for first degree program. This is the probability of enrolling for first degree program. So the complement should be 1 minus 0.642. So this one should be equal to how much? This one should be equal to 0.535. Right? So far, do you have any question? Please comment on chat room if you have a question. Do you understand? Yang lain-lain? Ada 84 dalam ni. Yang mana? Tak ada soalan ke? Right. So now, let's look at this one. Example number 7.16. Right. So, this is the last question. So, a product is selected at random, is found to be defective. What is the probability that the product produced is Y? So, this is simple. We want to find probability of the product is found to be defective, right? And we want to know whether what is the probability that product is from Y machine, right? So by using the Bayes theorem, Y intersect D divide by probability of D, right? So we already calculate probability of D complement, right? So this is 1 minus 0.919, and probability of Y intersect D should be equal to 0.45 multiplied with 0.93, right? So this one should be how much? 0.389, right? This is how we solve the problem. So by that we already finished chapter number 7. Right. So far in chapter number 7, do you have any question? Are you feeling terror already or not? Any questions so far? Right. Let's look at question on past year question. Right. This is example question December 2019. Right. December 2019, last year, which is the last semester punya soalan. Right. So now question number 8. Probability of A is 0.5, probability of B is 0.4, probability of A given B is 0.6. So we want to find probability of A intersect B. So to find probability of A intersect B, we need to use all the information given in the statement. So probability of A given B, it should be equal to probability of A intersect B divided by probability of B. Right. So this one should be probability of B multiplied with if you want to find probability of A intersect B, you should modify the formula. Probability of B multiplied with probability of A given B. So this one should be 0.4 multiplied with 0.6. So this one should be 0.24. right? 2 marks only. Should be very easy, right? The next question is, if you want to find probability of A union B, so probability of A union B is probability of A plus probability B minus probability of A intersect B. So you already have those value, just plug in into the formula. 0.5 plus 0.4 minus 0.24, right? 0.5 plus 0.4 minus 0.24 should be 0.66, right? And the last question is probability of A complement intersect B, right? So now, to solve this one, right, you need to draw a Venn diagram. We need to draw a Venn diagram. We have probability A, set A, and set B, right? So how do we know the set is intersect? So because the value of intersect is non-zero. So this is the A intersect B. Probability of A complement is somewhere not A. So this is yang warna orange, warna kuning ni adalah not complement of A. So everything non-A is A complement, right? This is A complement. A complement intersect B. So this is B, right? This is B. So yang intersect adalah yang warna hijau tu, right? So this is A complement intersect B. So how to find the value of this one? Should be equal to probability of B minus probability of A intersect B. So kalau the whole B minus probability A intersect B, you should get the green area, right? So that's why probability of A complement intersect B should be probability of B minus probability of A intersect B. So this one should be 0.4 minus 0.24. So this one should be 0.4 minus 0.24, 0.16. Right? So 2 marks. So now let's look at example question number B, right, for 2016, 19. Right, a lecturer is investigating the absenteeism problem among students from 3 classes named A, B, and C. Right, the number of student class A, B, and C are 20, 40, and 40, respectively. So now, so we have 3 classes A, B, and C. Right, the total number of student is how much? 100 lah, right? 40 plus 40 plus 20 is equal to 100. So 20 over 100, this is 40 over 100, this is 40 over 100, right? Basically kalau kita letak dalam bentuk percentage, right, dalam bentuk probability, this is 0.20, 0.40, 0.40, right? So the probability of absenteeism from class A, B, and C are 0.1, 0.3, and 0.2. So in class A, let's say we put T as tidak hadir, absent, T complement, T complement, T complement, and you should put some note here, right? T means absent, right? So 0.1, 0.9, 0.3, 0.7, 0.2, 0.8. So this is the probability of absent given from each class. So we already draw a tree diagram to represent the above situation, right? So now, if a student is found to be absent, find the probability that student is from class A, right? Probability of absent, right, from class A, right? So this is probability of A intersect T divided by probability of T. Now, from this one, we don't really know the probability of T, right? So we need to find the probability T. Probability T is the summation of all intersection with T, right? So let's do the denominator first. Denominator. So A intersect T 0.2 multiplied with 0.1 plus 0.4 multiplied with 0.3 plus 0.4 multiplied with 0.2. So this is what we will get probability T. If you want to find probability of A intersect T, it should be 0.2 multiplied with 0.1. So you calculate this one, you will get the value of probability of A given T. Right? So can you tell me the value of probability of A given T?
Zero point 0.66.
0. 0.6 what?
68.
68, right? Ini I tak kira, you kira kan? Right. So that's how we answer the question lah. Question number 8, 2019 December. Right. Now let's look at this one should be very easy. Right. This one easy. This one easy. Yeah. Let's look at question number 6. So how many different arrangements in the Putrajaya can be formed if there is no restriction? So now, and for Putrajaya, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Can you confirm for me? We have 9 letters in Putrajaya. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So, N, P, we have 1. And U, you have 1. And T, also 1. And R, you have 1. And J, also 1. And A, you have 3. And Y equal to 1. So the only repeated object is A. Right? So if there is no restriction, so we should use the formula n factorial divided by R1 factorial, R2 factorial until Rk factorial. So this one should be 9 factorial over 3 factorial. Right? Can you calculate for me? You should get 60480. Right? Now, the second question is if the vowel must be together. If the vowel must be together, so the word of vowel, how many vowel are there? So this is P, T, R, J, Y. So basically 1, 2, 3, 4, 5. So vowel we have, and V we have 5. And U, A ni we have 4. Right? So now, P, T, R, J, Y. So this is a vowel, right? And for non-vowel, we have U, A, and A, right? So the word of vowel, the vowel must be together. Maksudnya, we need to treat this one as one, right? So we're going to create this one as a one object. So now we have, let's say, one object ni kita letak sebagai the object yang tak ada dalam PTRGY. Let's say we name this one as X, right? Yang tak ada dalam ni. So now we have X, U, A, right? So now our n became 5. So we have 5 factorial divided by 3 factorial because we have 3 A's, right? So this is a repeated object, and we need to multiply with the combination of the vowel itself. So the vowel we have 1, 2, 3, 4, 5. Right? We have 5 factorial. So this is non-repeated object. So this is how we calculate we know how many different arrangement if the vowel must be together. Right? So this one should be 5 factorial multiply with 5 factorial divide by 3 factorial. So it should be equal to 2400. Right? So I think for the final exam question, you should download the final exam question paper from the library and try to do all the question one by one, right? So others question yang I tak sentuh ni semua soalan-soalan yang senang sajalah, right? Direct question, right? Okay. So far, do you have any question? Before we end our session, do you have any question? Right, please treat as this example question, final exam question, as your homework. Please do it by yourself. Right, you need to practice to do. If you not practice, then in final assessment nanti you akan tak boleh nak jawab. Right? Any questions so far? Please comment on chat box before we end our session. Hello. Right. Alright, good. So I think we should end our session now. I think that's all. Thank you very much, and Assalamualaikum.